Hello students, welcome to EduCell. In this video, we are going to discuss Kruskal algorithm, why it is important, how it is being done, that is also being discussed. Before that, I should be discussing the algorithm, then we'll discuss the steps to solve it. Okay, I'll write my own steps. And also based on the Kruskal algorithm, what is the time complexity that we'll get, we'll also discuss on this. So I told you I kept this information from Coleman's book, which is Introduction to Algorithm Design. Okay, so here are the algorithm is written by keeping two argument. One is graph and there is weight because we are working on the based on the weight and though we somehow entered into greedy approach, we'll discuss that also. Okay, and here the first it says A is a set which has no such element. You can say whether set is existing there in data structure. I must say it's no. The simple using of set is you can say use of array. Okay, we are using array as a data structure. Next, we are doing a loop. We are just running a loop. What exactly we are fetching? We are just keeping a small v, which is the vertices. G dot v is vertices, where we are just saying that function is make set. Means we are just making the set. Like these are the vertices set or vertex set. Okay, so it's a part of set theory we are discussing, but in computer science term, we must say we are storing in an array, so it's a array terms that we are using here. Okay, so next is the fourth one. It says whatever the ages, the weight of the ages we stored, that should be non-decreasing order, means in increasing order by weight w, the w which we have taken, so that will be in a non-decreasing order. You can say in an increasing order we are storing one by one, like we sort it. Okay, whenever we are collecting that one, that time we need to sort it. Which sort? That recently you studied heap sort. Okay, it is also written in Coleman. We are using heap sort because before that whatever the sort that we have used is not giving us n log n time. Okay, so it is less than n square, which we previously studied in selection sort, insertion sort, bubble sort. That time we studied uh, which time complexity is n square. That is why we are finding the heap sort as n log n. Okay, that is why whenever we are writing sort, that you indirectly think we are using the time complexity as n log n. Here n represents the vertices, though we are focusing on e, so that's why though we are focusing on edges, the time complexity could be e log e. Okay, this is what we expect. Although we are focusing on e, that's why the time complexity we are getting as this one. So here we are focusing on the v, clear? So you can say it's v, or you can say though we are focusing on edges, that time it would be written as e log v also, because on the basis of vertices we are finding the edges. That is why sometimes we are writing it e log v2, clear? Based on the vertices we are finding the edges, that's why. And for loop is running each edge, like each edge which belongs to g dot t, means the edges of a graph, clear, belongs to that one, taken in non-decreasing order by weight. You can write it small w also, which we have taken. Okay, so what it does, like it is writing the for loop, it belongs to something, it has some condition, which type of condition it is written clearly. Okay, so you can say based on the ages, means the total time complexity, I must say if condition is there, so it is big of 1 by default, and it is also big of 1, clear? It is also big of 1 means one time it is running inside the loop, but the loop will run for big of v times. Why? Because or big of e times also you can add, because it depends on the number of edges or the weights we are actually counting. So based on that, the number of edges we will collect, the number of times the loop will run. But within that, each statement is running for one time. Why? Because if condition is there and the statements are being written. That we discussed in the previous videos. Those who are new, kindly check the previous videos, the heap shot that we discussed now, that you please check the detailed video, and also check how the time complexity we are finding out. Also, if you are having any problem, there are problem solving sessions too. You can find the videos in our channel. Next, once the you have properly found out that UV means previously nothing was there as per this one, so you are adding that age to the set or indirectly the array. Next, you're doing that union means you combined it. Clear now? Next, return A. So this sixth statement says whether the find set and make set, the two different functions. Make set means you are collecting it and you are storing it. Find set means you are finding, u and v means whether the two edges, whatever the edges that you are finding, whatever the vertices that you are finding out, clear, whether there is a connection means whether these two different vertices are inside a tree, means you are creating MST. You are creating MST means like minimum spanning tree that you are creating. Whether the minimum spanning tree whichever you are creating, whether there are two different vertex, clear, two different vertices, whether they are within the tree or not. To find that one, we are using the sixth one. It is clearly written in the core method, but to make it simpler, I'm just saying in a single sentence to check the two vertices which we are actually taking in a loop. So we are using find set, means if they are not there, clear. So we are exactly finding they should be within the tree, clear. Next is the example I have kept, but before that I must say my steps. That would be very much easy for you to understand. Okay, steps, which is too easy for you to understand whenever you are going for the exam. That time it will be very much helpful to you. But before that, we must say the time complexity is now the time complexity could be written as, your written is also big of fun because one time it is getting written. Okay, so time complexity would be the combination of, here it's big of one because it's a statement, one statement one time it is running, so big of one. So here big of one, I'm just adding it because you are trying to find out the time complexity. The maximum will be picked as the time complexity, the worst time complexity. I'm just writing it's e log v plus, and in total I'm just writing for this for loop as e, clear, plus last there is one. So out of this, that the maximum is n log n or e log v. If you put v as n and e as n, you can say it should be the maximum time complexity we can expect. So in Kruskal algorithm, this is what the time complexity we are actually finding. Okay. Next is my steps which we discussed. Clear. First, what you have to write, you have to or sort all the edges in increasing order, and keep in the table. Clear. One table will create, well, keep the increasing order, that would be better. Then select minimum edge first, then the next minimum will be selected by keeping in mind that the new new edge should not create any cycle. Here the cycle property could be focused. So what you have to do, you have to first take a minimum edge. The minimum, the lowest one will be picked first. Then we'll carry on with the next minimum to the next minimum, or next maximum to the next maximum towards that. Clear? But the new edge, whenever we are adding it, we should have to check whether it is creating a cycle or not. If it is creating a cycle, then we switch to the next one. Okay, so when we will stop if all vertices have connected. Clear? So you have to stop if all the vertices have connected well. I'll run that example as written in the book. So here, first you have to maintain a table. Clear? That could be very much easy for you to understand. One side you can keep ages, another side you can say weight or cost. Clear? It's too easy to understand first. You can keep AB, that this type of edges we can write AB as the weight is 4. Now from A to H the weight is 8. That I'm not maintaining, you can say better we can start with the minimum one, because as we are doing in an increasing order, that could be better. If space is limited, we have to manage that one. So out of this the minimum is HG, which is 1. Next is, there are two options, either IC or GF. IC is 2, G2F is also 2. Next minimum we have is 4. Here A to B and C to F is also option. A to B is 4, then C to F is 4. Next minimum is, then 7 could be the next minimum, 6 could be the next minimum. Okay, so for 6 it's I to G, it is 6. So next minimum is 7, that you can take I to H is 7. C to D is also 7. I'm just writing C to D, I to H. Okay, and next is B to C is 8. B to C is 8. Next A to H is also there. uh, A to H, B to C is 8. Okay, next minimum is a 9 which is T2E. Clear. Next minimum is 10 and 11, 14. 10, 11, 14. We can keep one by one. Okay. So E2F is 10, D2H is 11. Next uh, D2F is 14. So number of edges are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, 13, 14. Okay, 14 that we have collected. As for this, what I told you in the step, it is written sort all the uh, in an increasing order. Why? Because if you are keeping an increasing order, the first will be selected. Okay, the minimum will be selected. Now we are going to select minimum. Here, as per the example, we have selected this G2H. Why? Because it is minimum. Okay. Next minimum is we have two options. Either or could be selected as per the Coreman. This is Coreman example. Okay. Coreman example. Uh, in our detail, this is the detailed video. So in detailed video, my first target is we should discuss an example within detail. Next, in our problem solving video, we have to keep one more diagram through which we could be easily understood from that one. Okay, just two, three different examples if I'll provide you through which it could be very much easy to understand. Okay, so next is that there are two options. Out of two options, you can select any of the option are the first. Here it is selected, so that is where we can say I to C. Next, it's not creating any cycle. We have to keep in mind the next will be not creating any cycle, that will be selected. Next, G2F, whether it will create a cycle. No, G2F is not creating any cycle. You can keep that one. And next is A to B. A to B, where it is clear. It's not creating any cycle. You can carry on, not an issue. Next, C2F. C2F is okay. Next, C2F. It's not creating any cycle, so we can keep that one. Next, I to G, whether it is creating any cycle or not. If I'll keep this one, so it will form a cycle. That is why we have to discard that one. Okay, we have to discard. First, we have to select it to check whether it is creating a cycle or not. If it is not creating any cycle, so we will select. We will be union that one. We are going to keep that one. Okay. Otherwise, we have to discard that one. Okay. So next we have to go for C to D. Whether C to D is creating any cycle or not, no. So we will select, we will do the union out of it. Okay. Next, I to H. I to H, yes, here is a problem. If I'll select this one, so it might create a total cycle. Okay. So you can say the cycle could be like this. So we have to avoid that one. So here we have to avoid. Now A to H. A to H, if I'll add this one, no cycle could be formed. So we can keep that one. B to C. B to C, if I'll take this one, it will be a cycle. Clear? So that is why we have to remove. Next, D to E. D to E, if I'll keep this one, no cycle could be formed. You can check here. Next, E to F. E to F, if I'll keep this one, so a cycle could be formed. That is why we should have to discard this. Clear? Next, B to H. B to H, this one, if I'll keep, so cycle could be formed. So we have to discard this. Next, D to F. If I'll keep this one, So a cycle could be formed. So that's why we have to discard this. So the total cost of the MST could be cost of the MST. So here more than one could be possible. Why? Because the edges are not distinct. Some edges are similar values. So those who have not visited the introduction one, kindly view the kindly watch the introduction video, through which it could be very much easy for you to understand. Okay. So now the cost could be written as A to B, which we have picked, or you can say from this tick mark, I'm just adding the cost 1, 2 plus 2, 4 plus 4, next plus 7, next plus 8, next plus 9. Okay, so 9, 8, 7, 4, 4, 2, 2, 1. This is what the cost, you can say, of the MST. Clear? So cost of the MST could be defined in this way, through which it could be better for you to understand. If I go for the totaling of it, it could be 10, 10, 20, 37. Okay, 37 could be the cost of the MST. Many MST could be possible because of the not uniqueness, or you can say it's a not distinct edges that we are keeping. That is why. This is how we have completed the finding of MST using Kruskal approach or Kruskal algorithm. Thank you for watching. If you are facing any doubt, please comment below. Have a good day.